Hello everyone. Today we will be covering rate of chemical reactions. We will be doing definition and graph, collision theory, factors affecting rate of reaction, and reaction profile. So first, what is the definition of the rate of a reaction? It's the time taken for the reactants to be used up or the products to be formed. So it has two definitions because there are also two different graphs, as we can see here. So this graph is for our reactants, where first when we start, the reactants is a lot in mass, and then as the time goes by in the reaction, the reactants decrease because it's being used up to form products. So now here we have our products, and as you can see, initially products is 0, and as the reaction progresses, our products increase, so it's being formed. So these are the two different graphs, and based on our two different definitions, we have two different formulas. The first one is quantity of products formed over time taken, and the quantity of reactants used up over time taken. So it's not that different. You just have to change the products and reactants, the time, and everything else stays the same. So collision theory states that in order for a chemical reaction to occur, the particles must collide with each other and have energy exceeding the activation energy to react. So activation energy is the minimum amount of energy needed for a reaction to happen. So there are many factors affecting the rate of reaction: temperature, concentration and pressure, surface area, and a catalyst. So in this picture we can see that these are the particles and they're colliding with each other. So they must collide with energy that is higher than the activation energy for the reaction to start. So this is a very key concept. You should know this. So now let's talk about the factors. So our first factor is temperature. So now, knowing what we know about collision theory, so temperature increases. So let's say our temperature increases. What happens to the particles? The particles gain more energy. So that means that they collide with more energy. So they collide with more energy. So that means that it's likely to exceed the activation energy. And when they collide, when they gain more energy, they also move faster. So they're hitting each other more frequently. So when temperature increases, rate of reaction also increases. So our second factor is concentration or pressure. So I'm gonna explain first after why these two are the same thing. And it's also to note that we use concentration for solutions and pressure for gas. So as the concentration and pressure increase, there are more particles per unit. So this means that there are more frequent collisions. So this means that the rate of reaction increases when concentration and pressure increase. So you don't have to really memorize any of this, it's just that you need to know the concept of it. So our next one is surface area. So when surface area increases, so does rate of reaction. So I'm going to explain this with an example. So we have three, okay, solids, a solid like this, a small chunks, so like this, okay, and we have powder. So based on your prior knowledge and experience, which one do you think will react faster, get used up faster? So the correct one is powder, obviously. So why is that? So that's because when the volume, because when surface area increases, we all know that volume increases. So when when volume and surface area increase, there will be more frequent collisions. So this means that the rate of reaction will be higher because there are more collisions happening. So as surface area increases, rate of reaction increases. Okay, now our final factor is catalyst and the presence of it. So catalysts, they're like substances that they speed up a reaction, but they don't get used up, and they don't change the reaction itself. They don't change the reaction. So it doesn't change how much product is formed. It doesn't change what product is formed. It just speeds it up. So now that we know the purpose of a catalyst, which is to speed up a reaction, naturally that means that it's going to increase the rate of a reaction when you use a catalyst. So now we have a reaction profile, the rate of reaction profile. So from here we can see that this is total mass of volume of product. So it's product, okay. And this is the time, obviously. So we can see here that this one is much slower. We can see the slope, it kind of like stops reacting, or all the product is finally used up around here. But this one, the purple one, the products formed much faster and they level out. So this one, it barely levels out around here. So this means that this one has a faster rate of reaction and this one is slower. So this is because this has higher concentration and pressure and this one has lower. So they can ask like our 4 factors in the form of a graph to see our understanding. So this could be low temperature, for example, and this can be high temperature. It doesn't matter, but you have to get it right, because when there's low temperature, the rate of reaction is lower, but when there's higher, it's higher. So you have to make the graph correctly. So that is it for today. Thank you guys for watching.